and welcome to our next video. Today we discuss further for the radius of curvature at the origin, Newton's method. At 0, 0, if we want to find out the radius of curvature, we have the tangent at the origin 0, 0, then how we have to find out the radius of curvature. So first, if x-axis is a tangent at origin 0, 0, if x-axis is tangent at 0, 0, then the radius of curvature at origin is given by a limit x tends to 0, y tends to 0, x square upon 2y. Similarly, if y-axis is the tangent at origin, then radius of curvature at 0, 0 at origin given by limit x tends to 0, y tends to 0 is to y square upon 2x. Clear? Next case, if both axes are not tangent at any place, but if y is equal to fx is our curve at 0, 0, then we have to find out the tangent radius of curvature at 0, 0. At 0, 0, find r. So for it, first we have to use the Maclaurin theorem. What is our expansion of this function with the help of Maclaurin? Means because Maclaurin express this function into series form at 0 point, at 0, 0 origin. So our function is f0 plus h, or we can say x upon factorial 1 f dash 0 plus x square upon factorial 2 f double dash 0 and so on up to n term. So this is Maclaurin expansion. With the help of Maclaurin expansion, we can say f0 is 0 if curve passes through origin. If curve passes through origin, then f0 definitely it satisfies. f0 is 0. So our radius of curvature at this condition r is equal to 1 plus y1 square to the power 3 by 2 upon y2 on a. Clear? So what is y1 and y2? 1 plus p square of 3 by 2 upon q only. So what is p? P, see here with the help of this Maclaurin theorem, p is the f dash of 0, or we can say y1 0, first order derivative. This is our p. And what is our q? F double dash of 0, second order derivative, that is our q. So we have to expand this. We have to find out the value of p and q. Substitute here at 0, 0 point, we will get the radius of curvature. And for finding the tangent at 0, 0, what we can do? We can do the lowest power derivative equating equal to 0, so we will get the tangent. In previous radius of curvature, you also see how to find out the tangent. We just compare the lowest order derivative equal to 0. Next is the radius of curvature for polar coordinate at origin or at pole. So radius of curvature, fourth case is, first one, if x-axis it passes through x-axis is tangent. Second one, if y-axis is tangent. Third one, if x and y both axes are not tangent, but we have to find out the radius of curvature at origin. And fourth one is radius of curvature at pole for polar line, for polar curve. R we can say for r and theta. So there are also two. First one is if initial line is tangent at pole. Is tangent at pole. Clear? If initial line is tangent, initial line means x-axis. Perpendicular line, that is 90 degree, theta is equal to, initial line means theta equal to 0 degree. So that is x-axis. For initial line, what is our x is equal to r cos theta, y is equal to r of sin theta. Then our at pole, r at pole for polar curve is given by limit x tends to 0, y tends to 0, x square upon 2y, because it is x-axis. Now convert, so it gives r at pole, substitute the values. So it gives 1 by 2 of limit r tends to 0, theta tends to 0, dr upon d theta. So this, when we convert, substitute these value here, applying the limit, we change the limits also, then we will get this radius of curvature for r theta through its origin pole at initial line. So now we go for some examples so you can better understand how to solve radius of curvature at the pole. So first question, determine the radius of curvature at 0, 0 for the curve x cube y minus xy cube plus 2x square y x minus 3x square 3xy x. Given curve is this, and we have to find out the radius of curvature at 0, 0 for this curve. So for at 0, 0, first we have to find out the tangent, then perpendicular distance, draw from the tangent, we have to find out the radius. So for tangent, what is the tangent? Lowest power term equating 0. Okay, so which is the lowest power term? This one. So we have to, if we have to equate 4x is equal to 0, it gives x is equal to 0. X is equal to 0 is a tangent at origin, is a tangent at 0, 0. So first step, we have to find out tangent at origin. First step is finished. We have to find out the tangent at origin. Now next step, we have to divide all equation with x. Divide equation with x. When we dividing this equation with x, our new equation becomes x square y minus y cube plus 2xy minus 2y square plus 2y square by x minus 3x plus 3y minus 4 equal to 0. Divide equation 1 with x. Clear? Because our tangent is x equal to 0. When we divide, now we have to apply the limit x tends to 0, y tends to 0. When x tends to 0 and y tends to 0, then what is the our radius of curvature? 2r, or we can say r equal to limit x tends to 0, y tends to 0. It is x equal to 0 means y axis is the tangent. So y square upon 2x. Clear? Y square upon 2x. So with this limit x tends to 0, y tends to 0, this y gives y, this term, this y square by x is equal to 2 of r. So we substitute this value here, 2 of r here. So we will get the value of r. So when we substitute 2 of r here, x tends to 0, y tends to 0, this becomes 0, this 0, this 0, this 0. There is 2r. 2 times 2r means it gives 4 of r minus of 4 equal to 0. So r is equal to 1. So radius of curvature for this given curve at the origin is 1. Clear? So it's very not very difficult to find out radius of curvature at origin. First you have to find out the tangent, then whatever the tangent, according to that you have to find the other process. Next we go for one example where radius of curvature, if we don't have any x-axis and y-axis is the tangent, then we use the Maclaurin. So question is, calculate the radius of curvature at 0, 0 for the curve a y square minus x square equal to x cube. So we have to find out the tangent. Tangent means equating the lowest power term equal to 0. So what is the lowest power term? This y square minus x square into a. So y square equal to a square. It gives y equal to plus minus x is the tangent. So tangent, this is tangent at 0, 0. So first step finished, we have to find out the tangent. After tangent, we find out the value of P and Q. We substitute it with Maclaurins. What is the Maclaurins? Maclaurins is the Px plus Qx square by 2 and so on. Clear? So what is y? Here we substitute this expansion to using 2 in 1. So substitute value of y, a px plus qx square by 2 and so on minus x square equal to x cube. Clear? P and Q. P is f of 0, value of function at 0 point. First order derivative, this is second order derivative. Clear? And value of function f0 is 0 at origin. So f0 we avoid. Otherwise, what is the Maclaurins? Y is equal to f of 0 plus f dash of 0 into x plus f double dash of 0 into x square by 2. So this is our P, this is our Q, and this value at 0 is always satisfy the equation at origin. If it is passes through origin, so this terms we omit. This is 0. So our term is y is equal to px plus qx square by 2. We substitute here. Clear? How this term will be? Now we have to calculate the value of P and Q. These unknowns. So what we can, in the both side, we can compare the alike powers. For example, first we have to compare the alike power. First we have to compare the power of x. Clear? So what is the x? When we compare it, power of P, this is y square. So first power is x square. Compare the power of x square. So what is the power of x square? A p square and then minus of a equal to right hand side no power of a p square minus a is equal to 0. So what is the value of a? What is the value of p? P is plus minus of 1. Similarly, compare the coefficient, compare the alike power x cube. X cube, when we compare, we have to, this is whole square. This is p square x square plus 2 times px cube and x square is x cube by 2 cancel plus q square x4 by 4 and so on. Means these terms like this. So when we compare the power of x cube, so this term is also x cube and no other. So what is the x cube term here? X cube term here is a p cube and right hand side is 1 only. So what is p? P is 1. So q is 1 by a and we can use plus minus because p is plus minus 1. So value of p is at origin is 1 and value of q is plus minus 1 by a. Now we have to substitute this in our radius of curvature formula. So what is our formula? Formula is r is equal to 1 plus p square to the power 3 by 2 upon q. Clear? So now substitute the value 1 plus 1 to the power 3 by 2 plus minus 1 square is 1 upon q is 1 by a plus minus. So 1 plus 1 is 2. So 2 to the power 3 by 2 is 2 root 2 upon 1 by a. So radius of curvature of given curve is this, or we can say 2 root 2 a. So this is our radius of curvature with the help of Maclaurin's theorem if our any axis is not tangent for the given curve. Next we go for of curvature. Center of circle of curvature is what? If we have any curve at this point it touches, okay, then if this point, if we can draw a circle with this, then this is the center. Clear? And this is one angle, we can say this is angle alpha, and this is another angle with this line. This is also alpha, this alpha, then this is also alpha, and if this point is our P, X, comma Y, and this is C, center of the circle. So what, and this is R, radius of curvature. So what is the center for circle of curvature? Center for circle of curvature means if we have any curve, we have to find out at that point we have to draw a circle with radius is equal to radius of curvature. Then we have to find out if R, we have to know radius of curvature, we can draw the circle. We have to find out this center value of x and y. So for that, what is R? R is radius of curvature. We can say 1 by k. K is curvature. Or in Cartesian, we can say y1 by 3 by 2 upon y2. Clear? For here, capital X is given by x because this line is x sine of alpha, and capital Y is given by x minus of r sine of alpha. Clear? So x minus r sine of alpha is given by x minus r sine alpha is y1 upon under root 1 plus y1 of square. So our formula for center of curvature is given by x equal to x minus y1 1 plus y1 square upon y2. y1 is first order derivative or y2 is second order derivative, and center of curvature second is y equal to y plus 1 plus y1 square upon y2. So these are the coordinates for circle which we draw with the radius is radius of curvature. So these are the coordinates. So how we find out, and if we want to find the equation of circle. So what is the equation of circle? Yes, x minus center square plus y minus y square equal to radius equal to r square. Clear? So this is the circle, equation of circle, and this is coordinate x and y is the center for the circle of curvature. Clear? So now we go for one example so you better understand how to find out the circle and center of curvature. So question is, find the center of the circle of curvature for this given curve and find the equation of the circle. So our given curve is xy, x plus y equal to 2 at point 1 comma 1. Clear? So this is curve, this is point. Step 1, first we have to find out the tangent. So for the tangent, if it is origin, we have to find out at 0, 0. We compare the lowest power term equal to 0. Now it is at some other point. So what we can, we differentiate one time with respect to x. When we differentiate, what is the curve? This is x square y plus xy square equal to 2. Clear? So this gives, differentiate with respect to 2xy plus x square y1 plus y square plus 2x y1 equal to 0. Clear? So this is our, from with this equation we can find out the y1. So what is our y1? y1 is, we can simplify it, 2xy plus y square divided by x square plus 2xy. Clear? This is our y1. After that we have to find out this at 1 point. Second, at y1 is at 1, 1 point. So y1 is at 1, 1 point is when we substitute x equal to 1, y equal to 1. So y1 is coming minus of 1. So y1 at 1, 1 point is minus 1. Second thing, we have to find out y2. For y2 we again differentiate this equation with respect to x. One more time. So I write here y1 at 1, 1 is equal to minus 1. We remove this all. Again differentiate this with respect to x one time. So this gives 2y plus 2x y1 plus this gives 2x y1 plus x square y1 y2 plus 2y y1 plus 2y y1 plus 2x then y1 square y1 into y1 plus 2xy y2 equal to 0. Clear? Whole each term. With this term, when you see, first differentiate with respect to x. So x is 1, 2y. When 2x is as it is, derivative of y is y1. Similarly, this gives 2x y1 plus x square as it is, y1 gives y2, sorry, not this y1, y1 gives x square y2. This 2y y1. This gives 2x is 1, 2y y1. Then 2x is as it is, y gives y1. So 2x y1 square, then 2x y2 equal to, with the help of simplifying we can find out the value of y2. y2 is, when you simplify it, it comes to 2yx y1 plus 2y y1 plus x y1 square divided by minus of 2xy plus of x square. This is our y2. Same process, we have to find out the value of y2 at point 1, 1. When we substitute x is equal to 1, y equal to 1, we will get y2 at 1, 1. It gives 4 by 3. So our y1 at 1, 1 is minus 1, y2 is 4 by 3. So now next step we have to find out the center of the circle. Center of the circle is x, capital X and capital Y. What is capital X? Capital X is x minus y1 1 plus y1 square by y2. So substitute x is equal to 1 minus y1 is minus of 1, 1 plus 1 square is 1, y2 is 4 by 3. Clear? Simplify it. So x equal to, we find x equal to 5 by 2. Similarly, y is equal to, when we find out the value of y, we substitute in the formula y is equal to y1 plus y1 square upon y2. Substitute the value of 1 plus 1 upon 4 by 3. So it gives y2 is equal to also 5 by 2. So our center for the circle of curvature is 5 by 2, 5 by 2 for the given curve at point 1, 1. Now we have to find out our equation of circle. For the circle, first we have to calculate the R also, radius of curvature. So for it, radius of curvature is what? R is equal to 1 plus y1 square, it is about 3 by 2 upon y2. Clear? So y1 is 1. So 1 plus 1 square is 1 to the power 3 by 2 upon 4 by 3. So what is our R when we calculate? R is 3 root 2. So I directly write here R is equal to 3 by root 2. R is this, X and Y. Center of curvature is 5 by 2, 5 by 2. Next step, equation of circle of radius R with point 1, 1. So what is X minus 5 by 2? X minus this whole square plus Y minus 5 by 2 whole square. X minus x1 whole square, y minus y1 equal to 3 by root 2 R square. Clear? You can open it and simplify it. When you just open the whole square, simplify it, you will get the simplified equation of circle. So that's all about the radius of curvature. We can learn many types of radius of curvature, then the circle at center of radius of curvature and the center for the center of curvature. Okay, thank you.